Good evening, everyone.
Good evening, sir.
Yeah, good evening, Bhavna. Right. So I sent some questions to you in the group. We'll solve those questions and close the class for today. All right. Maths. You don't have maths today, so we'll solve some problems. All right. We'll solve those three problems and then did you receive the questions?
Yes, sir.
All right. So read the first question. In the first question, there's a belt, conveyor belt. If I'm not wrong. Yes, there's a conveyor belt on which there's a block projected velocity v naught. I have to find the minimum velocity v naught for it to reach the other end of the belt. This v naught is with respect to ground. Belt is moving with velocity v. It has to reach the other end, which is length L. All right. So I'll start with the reference frame. I'll choose the reference frame ground. So with respect to ground, my FBD is normal reaction mg. The mass is m. Mg. Friction is towards left. Why is it towards left? Because kinetic friction is kinetic friction. Because the
Towards
motion
left.
of the block. Sorry, yeah, towards left. Motion of the block is towards right with respect to the belt. So friction is towards left. It's kinetic friction. Kinetic friction is easy to handle because it's directly mu mg, mu n. So which n is equal to mg here, so mu mg. So my net force is mu mg, which is equal to mass into acceleration. M gets cancelled out. A is equal to mu g. All right. Now I know the retardation. Retardation of the particle is mu g. Velocity is v naught. With this retardation, this particle is supposed to stop here. Projected from this end, it has to stop at reach this end. So it should just stop there. If it stops before that, it doesn't reach that end. So if it stops beyond that, then it's fine. It will fall off the belt. But for it to reach the other end of the belt, it should just stop there. So limiting value is this V naught should become zero at this end. So I'll write final velocity square minus V naught square is equal to 2 times minus mu g times L. So minus gets cancelled out. I'll have V naught is equal to root 2 mu g L. V square minus u square is 2as. Acceleration is negative. Final velocity is 0. Particle is retarding. So v square is 0 minus u square is v naught square is equal to 2 times acceleration, which is negative mu g into L naught. All right, is it clear? See, all that I've done is FBD. I found out the acceleration from FBD. From FBD I've written F is equal to ma. From where I got the acceleration. Acceleration is towards left because frictional force is towards left. Velocity is towards right. Acceleration is towards left means particle retards. So particle retards in a sense, it goes in slowing down, slowing down, slowing down. For it to reach this end, it has to stop over here at this end. That means after covering a distance L, it should stop. So I'll use v square minus u square is 2as. I'll use final velocity over there should be 0 after traveling a distance L. L naught v square minus v naught square is equal to 2 times A is mu g, which I found out from the FBD into L naught. So v naught is equal to root of 2 mu g L naught. All right. We have got nothing to do with this V. V is just a diversion. Whether this belt is moving or not, velocity required is this much itself, because velocity with respect to ground is V naught. Once I project this, whether V is moving or not, my kinetic friction is mu mg and acceleration is mu g. Whether the belt is moving or not, my acceleration is mu g.
Yes, sir.
And the question is, it should reach the other end of the belt. It should reach this point. All right. Okay. Let's try the next one. Today we'll not go ahead with the concept because the YPC students are missing. So we'll just do these three problems and close the class. And I'll give you some time for you to do some practice on your own and give some time to all subjects. All right, maths, physics, and chemistry. Give some time to all the subjects. Because all the subjects together will fetch you a rank. Okay, look at the next one. I've got a pulley, block, coefficient of friction is 0.3, mass m is 2 kg, force applied is 20 Newton. First of all, will the block move or not? Is the question. If a block moves, find its acceleration. So ultimately, we need to find acceleration. If the block doesn't move, acceleration is zero. If the block moves, I'll find the acceleration non-zero, some value which is non-zero. So how do I find it? This is massless pulley. So if this is 20 Newton, tension in this thing will be 10 Newton and 10 Newton. So tension in this thing is 10 Newton. 10 plus 10 is 20. So if I draw the FBD of the block from ground reference frame, I've got 10 Newton pulling towards right. This is a 2 kg block, 2g downwards, normal reaction upwards, friction is towards left. Why is it towards left? Assuming surfaces are smooth, block will tend to move towards right, friction will be towards left. Now I'll find out the limiting value of the friction. What is the limiting value of the friction? Mu into n. So 0.3 into 20, which is 6 Newton. So limiting value is 6, but applied is 10. So friction will 6 and the block starts moving. All right.
Yes, sir.
Now, so what is the net force on the block? 10 minus 6 is equal to 2 times of acceleration. F is equal to m into a. I've drawn FBD from a reference frame which is ground. I've written F is equal to ma. I'll get the acceleration. So acceleration is 2 meters per second square. That's it. Nothing more than this. But if I have to apply only 10 Newton force, would the block move? Instead of 20 Newton, if I have to apply 10 Newton force, would the block move?
No, sir.
No, sir.
And what would be the value of friction?
Friction. Sir? Sir, can
ఫ్రిక్షన్
you
వాల్యూ ఎంత ఉంటుంది? ఫ్రిక్షన్ వాల్యూ ఎంత ఉంటుంది? లిమిటింగ్ వాల్యూ 6 ఉంది. అప్లై 10 చేశాను. అప్పుడు ఫ్రిక్షన్ వాల్యూ ఎంత ఉంటుంది? లిమిటింగ్ వాల్యూ 6 ఉంది.
5 Newton.
కరెక్ట్. 5 న్యూటన్. బికాస్ 10 న్యూటన్, 5 న్యూటన్, 5 న్యూటన్ ఇస్ టెన్షన్, 5 న్యూటన్ ఇస్ టెన్షన్. సో ఇక్కడ 5 న్యూటన్ అప్లై చేస్తాను. దిస్ ఇస్ లెస్ దెన్ లిమిటింగ్. సో దిస్ విల్ సెల్ఫ్ అడ్జస్ట్ టు 5 న్యూటన్. సో ఫ్రిక్షన్ విల్ బి 5 న్యూటన్. ద బ్లాక్ విల్ బి అట్ రెస్ట్.
Yes, sir.
All right. Okay, let's look at the next one. A uniform chain is just at rest. All right, over a rough horizontal table with its 1 by eta part of the length hanging vertically. Find the coefficient of static friction between the chain and the table. Let this be x. This is L naught minus x. All right. Let L naught be the complete total length of the string. All right. Now, what he says, this is just at rest. Ante x ని ఇంకా కొంచెం ఇంక్రీజ్ చేస్తే స్లిప్ అయిపోతుంది. See what is happening actually. ఇది ఎక్కువ పోర్షన్ ఉంటే నార్మల్ రియాక్షన్ ఎక్కువ ఉంటుంది. నార్మల్ రియాక్షన్ ఎక్కువ ఉంటే మై లిమిటింగ్ వాల్యూ విల్ బి మోర్. This is external. This part is external part, which is this force due to this is external force, which is pulling the string downward towards right. ఈ పైన part ని towards right pull చేస్తుంది. ఈ part x hanging part is pulling it towards right. ఇది ఇంక్రీజ్ చేస్తే నార్మల్ రియాక్షన్ తగ్గుతుంది, బట్ ఎక్స్టర్నల్ ఫోర్స్ ఇంక్రీజ్ అయిపోతుంది. నార్మల్ రియాక్షన్ తగ్గితే లిమిటింగ్ వాల్యూ తగ్గిపోతుంది. లిమిటింగ్ వాల్యూ తగ్గిపోతుంటే స్లిప్ అయ్యే ఛాన్సెస్ ఎక్కువ అయిపోతాయి. సో దేర్ విల్ బి వాల్యూ ఆఫ్ x ఎట్ విచ్ ఇట్ విల్ జస్ట్ స్టార్ట్ స్లిప్పింగ్. నేను స్ట్రింగ్ మొత్తం పైన పెట్టి కొంచెమే హ్యాంగ్ చేస్తే డెఫినెట్లీ స్లిప్ కాదు, రైట్? బట్ ఇఫ్ ఐ గో ఆన్ ఇంక్రీజింగ్ దిస్ పార్ట్, at some point it will start slipping.
Yes, sir.
And that is what he's saying. It is at just that condition. It is just at rest. It is just about to slip. That means force because of this one is counterbalanced by the frictional force over here. That means limiting value over here is exactly equal to the force due to this one. Okay. So let the linear mass density be lambda. Lambda is equal to m by L naught. So FBD of the upper part would be, FBD of this hanging part would be around the FBD. Lambda xg, downward gravitational force, tension upwards. On the table ఎలా ఉంటుంది? Tension rightwards, friction leftwards, which is mu times n. n ఎంత ఉంటుంది? Lambda times L naught minus x into g. Because
Sir,
my norm, yes, yes, Bhavna.
lambda, sir. What is lambda?
Lambda is linear mass density, mass per unit length. Total mass m ఇస్తే ఇలా అనుకో, మాస్ లెంత్ కి మాస్ m ఉంది, లెంత్ x కి ఎంత ఉంటుంది మాస్? m ఇంటూ x బై ఎల్ కదా.
Yes, sir.
సో m ఇంటూ x బై ఎల్ అంటే ఈ m బై ఎల్ ని లాంబ్డా అంటారు. లీనియర్ మాస్ డెన్సిటీ, దట్ ఈస్ మాస్ పర్ యూనిట్ లెంత్. టోటల్ లెంత్ కి మాస్ m ఉంది, ఒక యూనిట్ కి ఎంత ఉంది? Alright, so there are three kinds of densities I told you: linear mass density, surface mass density, volume mass density. Linear mass density is mass per unit length, surface is mass per unit area, volume is mass per unit volume. Alright, we are dealing with mass per unit length now because it's a linear chain, thin chain. We are dealing with mass per unit length. Sarana
Okay.
Bhavna?
Okay, sir.
Okay. Okay, now look at this. After this, we'll complicate this problem a bit, but ఇది అర్థమైతే అది చేయొచ్చు. That will be just mathematical, but you understand this process carefully. ఇక్కడ ఏమవుతుంది? Tension will be equal to lambda xg because it's in equilibrium, right? So lambda xg ఇక్కడ exert అవుతుంది, lambda naught xg ఇక్కడ exert అవుతుంది towards right, and that is being counterbalanced by this one exactly. So my limiting friction is equal to lambda xg. So lambda naught L naught minus x into g into mu is equal to mu into n is equal to external force applied. So lambda gets cancelled out, g gets cancelled out, mu is equal to x by L naught minus x. Alright, is it okay now?
Yes,
And
sir.
he said this is 1 by eta part of total length. So 1 by eta of L naught is my x. So L naught by eta is my x. ఇక్కడ సబ్స్టిట్యూట్ చేస్తా L naught by eta ని. So which I get as L naught by eta by L naught minus L naught by eta. So L naught also gets cancelled out. I'll have eta by eta minus 1 as my mu. Is it okay? ఇక్కడికి physics of the problem అయిపోయింది. Here I have equated the limiting value of the friction to the external force applied, which is tension. Tension ఎలా వచ్చింది నాకు from this vertical portion, in which tension is equal to lambda xg.
How, sir? Sir, అది ఎట్లా?
దీనికా see, for this vertical portion, T should counterbalance this one because this is at rest. T minus lambda xg is equal to 0.
Yes, sir.
So T equal to lambda xg. And this T is being applied here. For this, this is also at rest. If this is at rest, limiting value should be equal to tension. Tension ఎంత ఉంది lambda xg. Limiting value ఎంత ఉంటుంది mu into n. What is n? N is equal to mg. What is m here? Lambda into L minus x is m. ఇక్కడ lambda into x is m. ఇక్కడ lambda into x, L minus x is m. Because my linear mass density is lambda. Mass length L కి mass m ఉంది. Length L minus x కి mass ఎంత ఉంటుంది? L minus x into m by L.
Yes, sir.
ఈ m by L ని నేను lambda అని అంటున్నాను. So lambda anyway gets cancelled out. That means irrespective of what the mass on the string is, if this is hanging portion is 1 by eta of the whole length, my mu is going to be this one. Or if I know mu, I can find out eta from here. For a given mu, eta is same for independent of the mass of the string. Look at this, lambda is getting cancelled out, g is also getting cancelled out. So even if I take this in a lift, పైకి యాక్సిలరేట్ చేస్తూ ఆర్ కిందకి యాక్సిలరేట్ చేస్తూ నాట్ ఈక్వల్ టు జీ, అప్పుడు even if it equal to g, that doesn't matter, but not equal to g, I am insisting because okay, that will lift లో మాట్లాడదాము, తర్వాత మాట్లాడదాము. But now, so lambda is getting cancelled out. That means it is independent of the mass of the string. Mass 10 kg string ఉన్నా 2 kg string ఉన్నా, this will be configuration ఇలానే ఉంటుంది. X will be 1 by eta part of the length, 1 by eta of the length L naught. Whether you are accelerating in a lift or on gravity or on moon or on earth, g by 6 ఉన్నా g ఉన్నా ఏమైనా ఉన్నా, my configuration is going to be this itself for it to just slip or just be at rest. All right. See, all I've done is I've drawn FBD. From FBD, I got F is equal to ma. Acceleration is 0. So I got net force is equal to 0 situation వచ్చింది because particle is at rest అని చెప్పారు, ఈక్విలిబ్రియం అని చెప్పారు మనకి. So T is equal to lambda xg ఇక్కడ, T equal to limiting value ఇక్కడ. But what is limiting value? Mu into n. What is n? N is equal to mu m. N is equal to mg. What is m? Lambda into L minus x into g is n. ఇక్కడ ఫిజిక్స్ ఆఫ్ ద ప్రాబ్లం అయిపోతుంది. జస్ట్ సింప్లిఫికేషన్. ఈ సింప్లిఫికేషన్ సాల్వ్ చేస్తే I'll get mu is equal to eta by eta minus 1. Check if it's correct. Is it correct? Eta by eta minus 1 is correct? Yeah, it's correct. Students, అర్థమైందా ఈ ప్రాబ్లం?
Yes.
I'll send one more.
Sir,
Yes.
లాంబ్డా సార్ అది ఎందుకు వచ్చింది సార్ లాంబ్డా?
ఏం లేదు, ఇక్కడ m by l into n minus x ఉంది కదా,
ఎస్ సార్.
ఈ m by l ని ఒక టర్మ్ ఇస్తున్నాను లాంబ్డా అని.
సార్ అక్కడ కాదు సార్, ఆ ఈక్వేషన్ లో.
ఇక్కడనా?
నో సార్, ఇటు రైట్
ఎటు?
సైడ్.
ఇక్కడ
T
ఇట్లా?
టు లాంబ్డా ఇంటూ xg సార్.
ఓకే ఓకే ఓకే, ఇక్కడనా? చూడు, టెన్షన్ ఇస్ టీ అప్వర్డ్, లాంబ్డా xg కింద, mg కింద ఉంది. బట్ వాట్ ఇస్ m? మాస్ లెంత్ కి మాస్ m ఉంది, x కి మాస్ ఎంత ఉంటుంది? m ఇంటూ x బై l కదా.
ఎస్ సార్.
m బై l ఏంటి?
లాంబ్డా.
లాంబ్డా xg mg. Tension is counterbalanced by mg.
Okay, sir.
అర్థమైందా? Or you still have a doubt? Bhavna, is it okay? Like, you can ask me, that's okay.
Yes, sir, it is okay.
All right, all right. Okay, now look at the next question. We'll solve this question and then end up the class. Manchi question adi. Or if you want to try that question on your own, you can try. We'll close the class now. We'll end the class now. You want to try that question or should I solve the question? ఒకసారి క్వశ్చన్ చదవండి, బాగుంది క్వశ్చన్, మంచిగా ఉంది. Students, friction low, block on block problems are very critical. All right. So block on block, we'll do it tomorrow at the end of the session, towards the end of the session. But for now, I want you to read this question and understand whether you are able to think about the question. Idea వస్తుందా? Idea వస్తుందంటే you can try it on your own. Otherwise, I'll initiate the idea and we'll end the session. All right. Second question పంపించాను చూడు ఇప్పుడు. A thin rod of length 1 meter is fixed in a vertical position inside a train, which is moving horizontally with an acceleration of 4 meters per second square. A bead can slide on the rod and friction coefficient between them is 1/2. If the bead is released from rest at the top of the rod, find the time when it will reach at the bottom. You want to think about it? I suggest you give it a deep thought. కావాలంటే ఇనిషియేట్ చేస్తాను, thought process initiate చేస్తాను, but solving it on your own is a good thing. Answer రాకున్నా కూడా, but if you just get the thought process, that's a good thing. అక్కడ ఏమవుతుంది? See, there is an accelerated reference frame. So let us stand on the accelerated reference frame and draw the FBD of the bead.
Sir.
FBD draw is, yes, Bhavna?
No, sir. No, sir.
Okay. So FBD draw చేసి write F is equal to MA and see whether the particle is in equilibrium. Equilibrium లో ఛాన్సెస్ ఉందా? లిమిటింగ్ వాల్యూ కనుక్కోండి, స్టాటిక్ ఫ్రిక్షన్ కి FL కనుక్కోండి. If external force is beating FL, it will slide down. If it is not beating FL, it will stay there. నిన్న చేసాం చూడండి, ఒక బ్లాక్ ఉంది మార్నింగ్, ఇంకొక బ్లాక్ ఉంది, బ్లాక్ is moving with an acceleration A0. Will the block remain at rest or will it come down? Pseudo force ఉంటుంది. If I stand on this block, there is a pseudo force here. Normal reaction ఇలా ఉంటుంది. Normal reaction and pseudo force are counterbalancing each other. Because of this n, I'll have friction, limiting friction as mu n to n, and this is mg. If mg is beating mu n, it will stay there. Sorry, it will strip down. If mg is not able to beat mu n, it will stay there. With respect to the block, it will be at rest. Same thing we have to do here. Instead of a block here, I have a rod here. Rod ఉంది, ఒక bead ఉంది. So I'll stand on this platform, pseudo force draw చేస్తాను, 4 times mass of the bead or mass into acceleration నేను draw చేస్తాను. నార్మల్ రియాక్షన్ ఇలా ఉంటుంది, ఫ్రిక్షన్ పైన ఉంటుంది, గ్రావిటేషన్ ఫోర్స్ డౌన్వర్డ్ ఉంటుంది. ఆల్ యూ హావ్ టు డూ ఇస్ చెక్ వెదర్ mu into n is sufficient to counterbalance mg. లేకుంటే స్లిప్ అవుతుంది. That's what he's also mentioned that it's slipping down. Now all that you have to do is find the acceleration, downward acceleration, and write half a d square. L is equal to h is equal to half a d square, or s equal to ut plus half a d square. U is equal to 0. All right. Will you try this now? Later? Students, I suggest you try this question. We'll discuss this tomorrow. All right.
Sir, acceleration 5 newtons of
5 meter per
5
second square వస్తుందా?
second square.
5 meter per second square వస్తుందా acceleration? డౌన్వర్డ్ యాక్సలరేషన్ ఎంత వచ్చింది?
5 meter per second, sir. 5 meter per second.
5 వస్తుందా? Okay, what is the pseudo force you have applied? 4m, right?
Yes, sir.
And this is 10m. So normal reaction ఎంత ఉంది? 4m. So mu into 4m ఎంత ఉంటుంది? 2m. So 10m minus 2m is equal to m into acceleration. M gets cancelled out. So acceleration is equal to 8 meters per second వస్తుంది నాకు, second square. Check. I could be wrong. G is 10 తీసుకున్నా నేను. I'll write it again. So I'll have mg minus mu n is equal to mass into acceleration. So mg minus mu times m into a naught, m into a naught is acceleration in the reference frame, is equal to mass into acceleration a required. So m now gets cancelled out. So I'll have a is equal to g minus mu into acceleration of the reference frame, which is 10 minus 2.
8.
8 వస్తుంది కదా, 8 correct కదా?
Yes, sir.
Okay, so where did you go wrong, Bhavna? Like where did you get 5?
Normal reactions, sir.
Oh,
Normal
okay, okay.
reaction.
Okay, okay.
Sir, అనుకున్నాను.
Oh, all right. Normal reaction is towards right. All right. Because with respect to this surface, pseudo force is towards left. That is counterbalanced by normal reaction, which is towards right. All right. ఇదే క్వశ్చన్ ని గ్రౌండ్ రిఫరెన్స్ ఫ్రేమ్ తో కూడా చేయండి. గ్రౌండ్ రిఫరెన్స్ ఫ్రేమ్ లో సూడో ఫోర్స్ ఉండదు, బట్ ఎంఏడి మారిపోతుంది. ఇక్కడ ఎంఏడిలో ఏముంది? కింద యాక్సలరేషన్, డౌన్వర్డ్ యాక్సలరేషన్ ఉంది, రిక్వైర్డ్ యాక్సలరేషన్ ఏ ఉంది, బట్ ఎంఏడి ఆఫ్ ఫ్రమ్ గ్రౌండ్ ఫ్రేమ్ విల్ బి డిఫరెంట్. ఆల్ రైట్. డ్రా దట్ అండ్ ట్రై దట్ టుమారో. ట్రై దట్ ఆఫ్టర్ ది క్లాస్. ఫ్రమ్ గ్రౌండ్ ఫ్రేమ్ కూడా ఈక్వేషన్స్ రాయండి. ఆన్సర్ సేమ్ రావాలి. యాక్సలరేషన్ షుడ్ బి 8 డౌన్వర్డ్. డౌన్వర్డ్ యాక్సలరేషన్ 8 ఉండాలి, బట్ your MAD and FBD will be different. FBD, all the real forces will be there except the pseudo force. Pseudo force, you not have a pseudo force on ground frame. All right. So once you get acceleration, I'll get H is equal to half a t square, which is 1 is equal to half a t square for t is equal to 0.5 seconds. All right, it will take half second for it to come down. All right, students, let's close here. Thank you so much. Good night and good luck. Students, you please try this problem from ground reference frame. All right, ground frame nunchi try cheyandi. It's the same thing except you will have MAD and FBD a little different. All right, reasoning, equation reasoning meaning వేరే ఉంటుంది. ఇప్పుడు మీనింగ్ వేరే ఉంది. నార్మల్ రియాక్షన్ ఎలా తెచ్చానో అది డిఫరెంట్ ఉంటుంది. నార్మల్ రియాక్షన్ ఇక్కడ ఎలా తెచ్చాను? n మైనస్ ఎంఏ ఈక్వల్ టు 0 అని తెచ్చాను. గ్రౌండ్ ఫ్రేమ్ లో అలా ఉండదు. నెట్ ఫోర్స్ కూడా మాస్ ఇంటూ యాక్సలరేషన్ అని వస్తుంది. MAD and FBD will be little different. All the real forces will exist. Pseudo force will not exist in ground frame. MAD will be little different. All right, try that from ground frame and try to answer it. Try to check your answer with this answer which we got just now. All right, students, thank you all. Bye, everyone. Any doubts? All right.